In the previous video, we worked on how you can derive a formula for the sine rule. Now in this video, I'm going to be taking you through how you can solve or how you can derive a formula for the cosine rule. So without wasting any further time, let's jump straight into our diagram. Now we're going to do the same thing that we did in our previous video. First thing that we need to do here is we need to make sure that we give this triangle a name. So let me just call it triangle ABC. All right. Now, once I do this, you need to also take note of the fact that this side now is going to be side B, this one is going to be side A, and then that one is going to be side C. All right. Now, how do you then derive this formula? So the first thing that you need to do here is you need to construct, just like we did in the previous video, a right angle triangle. Now, by doing this here, I'll then give this side or this corner or this vertex angle D. And then from here, this will be H, of course, and that will be X. Okay. Now, when you're solving or when you're deriving a cosine rule, there are two things that you're going to do, right? Cosine rule is more mainly focused on side, right? So it means here we're going to, number one, make use of Pythagoras, right? And then also make use of cos, right? Or cos ratio. All right. Now, how do we do that? Now, here, we only apply these two things when we have a right angle triangle. Now, in this case here, I'll say in this case, in triangle ADB, right? If I calculate Pythagoras there, I'll see that x squared plus h squared is equals to c squared. All right. Now, this is what I get here when I calculate Pythagoras in this triangle, right? Okay. Now, what about the other triangle? The other triangle will be in triangle ADC, right? Now, when we talk about triangle ADC has AD, AC, and DC is the whole part, right? So which means now by applying Pythagoras there, we'll say x plus a. So x plus a will be the side for DC because it's going to be from here to there, right? Let me just use a different color for this. So it's going to be from here up until there, right? Combining this x side and that a side. So we're going to square that plus h squared, which is going to be that side, equals to b squared, which is going to be our hypotenuse, right? Now, from getting this, you then see that from this part, once you simplify that one, you get x squared plus 2ax plus a squared plus h squared equals to b squared. All right. Now, once you have these, what is then the next step? The next step here is to make sure that you get rid of the unknowns because we don't actually know what is the value for x and as well as the value for h squared here, right? But then now from this formula, having these two formulas, we can see that here in the formula 1, we can take h squared and make it c squared minus x squared. Now, how do we do that? We just take this x squared across, right? Now, by having that, therefore, this means now this equation that we had earlier, which is x squared plus 2ax plus a squared, can now substitute h squared into c squared. Let me just use a different color. C squared minus x squared, right? Now this will still be equals to b squared. Now why are we doing this? We're doing this because by doing that, we get to cancel that one out. All right. So now what I'm going to do here is I'm going to write this in the right order by putting this b squared in front. And then from here, I have 2ax and a squared and c squared. So I'll start with a squared, then I'll go to c squared, and then I'll say plus 2ax. All right, now what do you notice here? We got rid of h squared, but then now we still need to find x. Now where do we see x here? So x here is located in triangle ADB. So what does this mean? So this means now what we're going to do is we're going to go back in triangle ADB. Now by getting into triangle ADB, we're going to apply, or we have to apply, what? A cos ratio there, right? So therefore here you're going to say cos of a certain angle, right? Now which angle? So this is the angle we're going to be focusing on. This is the angle we're going to be focusing on. Why? Because we want this angle to relate with x and this side, which is going to be a known side. Now how do you write that angle? Now in order for you to write that angle, if this angle was already angle B, then now with this angle, to get it, what we need to do is we need to subtract B from 180. So this means now this angle that we're looking for, it is going to be 180 minus angle B. So now that is the angle we're going to be using here. We're going to say cos of 180 minus B is equals to, now by doing that, then this means our adjacent can then now be x, and then the hypotenuse can be c. Alright, now 180 minus b belongs in the second quadrant, which means this, when simplified, it will be negative cos of angle B, which is x over c. Then now having this, we'll then cross multiply our c to that side. Then by doing that, we're going to have negative c cos B, which will be equals to x. Now this means now here we have our value for x. Therefore, we're going to go back into our original equation, or with the equation that we had, x is our unknown. Then now what are we going to do in this value? We're going to substitute our value for x, which is going to be minus c cos B. And then from here, we're going to simplify, which will be a squared plus c squared. Now positive times negative gives me negative, so this is going to be 2ac cos B. And that is how we then derive our formula. Now the easy way to do this, if you want to take note of this, the easy way to do this is that here it is more like a Pythagoras, the first part. Then here we just have this minus 2ac cos B here, right? So I always say that in order for you to understand this formula, you must always have two sides, right? And the included angle D. As you can see here, the two sides are known, and then that is going to be our included angle. All right. Now let's go ahead and do the other triangle, which is the acute one. Let me just call it angle cos, sorry, triangle cos. And then from here, we're going to do the same thing. But then now remember, just like we did on our previous video, when we were deriving sine, we had our vertical height here, and then we had h there. All right. Now we know that this whole side here, it is side C. So I'm just going to do it like that, and then I'll write C here. So now here, because of we've broken this triangle into two triangles, and then I'm going to write this as side, let me just call it I, all right, or let me call it Q, all right. So having this like that, so because of now we've broken this triangle COS into two triangles, right? Then now by breaking it down, this means this side we can then call it X, right? But then the other side, it will then be C minus X, all right? Because we're taking the bigger side and we're subtracting this smaller side that we just introduced right now. Okay, so now what I'm going to do from this is I need to write the sides, that side, which is side S, and this one is going to be side O. Now this is a big capital letter O, just to be clear. All right. Okay, so now how do we then derive the formula in an acute angle triangle? We basically do the same thing. We first make sure that we apply Pythagoras, and then from there we're going to use cos just to solve for an unknown, right? So we always try to make sure that we get rid of h first. So how do we do that? Do the same thing that we did here in the previous slide. We're going to start by looking into triangle COQ. Then from there, we apply our Pythagoras. So I can see here 8 squared plus x squared is equals to, or use s squared, right? And then from here, we find that 8 squared, which is what we did earlier, because we're going to use this to cancel out the 8 squared. So this becomes s squared minus x squared. All right. Then from here, what do? We look for another triangle. So we look into another triangle. So in another triangle, so in this case, it will be triangle CQS. We'll then do the same thing. 8 squared plus c minus x, which is our adjacent in this case, is equals to o squared. Now by simplifying this, we have 8 squared plus c squared minus 2cx plus x squared. This is equals to o squared. All right. Now do you see here we getting the same 8 squared that we did in our previous slide. So this means now what we're going to do here is we're going to substitute that 8 squared in there. So by substituting, we're going to have a squared minus x squared. All right. So that means we're going to say plus c squared minus 2cx plus x squared equals to o squared. Then now look what happens here. The x squared cancels with that one. And then now what do we have left? From there, we are left with s squared plus c squared minus 2cx equals to o squared. And then we can basically do the same thing that we did there, which is to write this in the correct order. That is by starting with o squared equals to, I can then now here say c squared plus s squared minus 2cx. Now we need to find x. Now how do we find x? So we go back into that triangle where we had our 8 squared equals to s squared minus x squared. All right. So now there we apply cos of an angle. So now here we do have an angle already. It is angle O. So we're going to say therefore cos angle O, it is going to be equals to our adjacent, which is x, our hypotenuse, which is s, and then we're going to cross multiply there. Then s cos angle O gives us x. Therefore O squared will then be c squared plus s squared, and then we're going to substitute that 2c into s cos O, and then now finally when we finalize this, it will then be s squared minus 2cs cos O. All right, and that is basically how we do the differentiation, or how we find this formula for the cosine rule in an acute angle triangle. And that's it for this video. If you like the video, please leave a comment. Tell me what you think about this video. Also, it is very important that you also share with your friends. That way, you guys will also be able to understand both of you, and also all of your friends will be able to understand this, and you'll be able to work together when you're practicing. This won't be then more challenging for you. Now in the next video, I'm going to be sharing more videos of how you can basically apply this, but before that, I'm going to share a video on how you can basically know when to use which formula, and I'm going to see you onto that video. Cheers.